Thanks very much. Thanks for the invite to come and talk a little bit about our perspective on immersive training. I'm the CEO and co-founder of Fundamental VR. We have a platform called Fundamental Surgery, and it's designed really for one universal challenge, which I think all of the talks today have been laddering up to, which is that it's complex, right? It's difficult to create environments within which safe training and learning and understanding can happen. And what we're trying to do with our tech stack at Fundamental VR is to create the opportunity to do that within immersive and spatial technology. We are completely hardware agnostic. We are procedural agnostic. We've been at this now for 9 years and have tried to develop a platform that's as scalable as possible so that it can be transported in your briefcase and in some fidelities in a carry-on case, but nothing bigger than that. I think when I think about VR, really, it's, for me, and for VR, read immersive technology within this space. It's really a case of this. It's not a case of if it has a role, and all of my colleagues here today have been talking about different perspectives on it. It's not a case if it has a role in both the residency and the ongoing training needs of healthcare providers. It's more a case of when it becomes an established part of everyday practice. And I think some of the work you're doing with Dutch is probably right at the forefront of that adoption curve. It's certainly not easy to put this in place, but it's proven. You know, the modality is proven across countless validation studies and real-world experience. When we look at the different modalities of virtual reality, whether it's the standalone virtual reality headsets that you're all, I'm sure, familiar with and have used in some way, I'm sure, the comparison of virtual reality training versus basic cognitive skills, knowledge acquisition is pretty impressive. Different studies range from a 50% to a 250% increase in the capability and the the knowledge acquisition of individuals using VR over traditional training techniques. And traditional in these validation studies is generally video and didactic. But however you measure it, providing the opportunity for repetition has been a key part of how VR within this modality, this standalone headset plus controller or headset plus hand tracking, how that can really make a difference to the education pathway. When you add in haptics and start thinking about how haptics in a scalable, immersive technology environment, again, something that you can put into your briefcase or take onto a plane as a carry-on or put easily into the back of a car. When you look at haptics versus virtual reality, what you see there, again, depending on the study you look at, is somewhere between a 30 and a 50% increase. And this time we're talking about skills acquisition. So this isn't comparing to traditional training. This is saying, okay, standalone VR versus haptic VR, what extra do you get? And what you get from haptics when married up with spatial technology is that skills acquisition, that muscle memory, that ability to move the dial faster when it comes to the physicality of involvement. And there's been a lot of discussion on haptics today, so I think all the groundwork's probably been done for me on that one. So what we've done with Fundamental Surgery is really create a multi-use case, cross-discipline training system for teams. You can use it individually, you can use it en masse, depending on the use case and the requirement. I won't go through all the details on this, but as I was alluding to, it deliberately carries both a standalone virtual reality use case, which is great for residency, great for early stage knowledge acquisition, as well as a haptic VR system that allows you to then take it to the next level, particularly for that ongoing training. You know, we never stop learning in this space. We never, ever have a situation where there isn't a new technique or a new piece of equipment that has a learning curve attached to it. Well, that's where those things can really start to, those systems can really start to work, and the haptic VR system can work there. And all of it with collaboration, whether you're in a standalone headset, you're in a haptic headset or haptic system, collaborating as a team whether that's on an OR setup or whether it's on actually running through a specific procedure, that's essential. And again, whether you're just on a different floor or in a different continent, the ability to bring people together fast, whether those are experts or just the team themselves, is essential. And so, again, within the tech stack that we've built, it allows for that to happen. And all of it, as my colleagues have already been alluding to, all of it driving immense amounts of data around your interactions, your knowledge points, your adverse effects, the telemetry of your hands within the haptic system, your head movement, your eye movement, all of that data being assessed and drawn into a number of algorithms and systems that we have built within the background of the system. So I'll spend the last few minutes, because of the theme of this particular conference, talking about those elements and how those are starting to be deployed today. The use of these systems really, for us, falls into two areas. One of them around knowledge and expertise, and the other one around guidance and advice. So taking the first one, knowledge and expertise, first of all, as you saw in the last presentation, providing guidance in real time is an interesting and developing space. But starting with basic knowledge and being able to deliver that at the right time to the user inside a virtual space is a simple and natural step. So we've built something we call Maya, which is our medical AI assistant. And he or she, depending on how you listen to the voice, talks to you, much the same as you saw previously. You interact with that person, that bot. And we can feed into that bot instructions for use, validation studies, teaching, transcripts, all of that material, constrain it very carefully so that we avoid hallucinations, and provide that in real time to the user within the space. And this is a really simplistic, very quick example of that in one of the environments that we have. And as you'll see, it's a very simple play out. I hope the sound's going to work.
Hello, what do you do?
I provide concise medical answers and information about our VR simulation environment.
Can you tell me about the equipment in this room?
The room includes an anesthetics machine, IV pole with infusion pumps, Mayo tables, mobile ceiling supply units, media library console, interactive whiteboard, C-arm, and a large procedure table.
How can I best manage a coronary perforation during PCI?
Immediate management of coronary perforation during PCI includes prolonged balloon inflation, covered stent deployment, and consideration of coil embolization.
So that's kind of the extremes of the questioning that you might have within this space, clearly. But the point hopefully is made there in that very simple video that by delivering this information into this system and then having it there with a simple text-to-speech and speech-to-text interface, it means that we can start to digitize all the expertise in this room, potentially. Constrain it and deliver it to the trainee, whether that's a resident or whether that's a fellow that's trying to learn a new technique, deliver it in real time within those environments at the point where it's needed. And we can take it a step further. We can then provide the guidance that comes with that as well, because as I said, we have that telemetry data. We understand where your hands are. We understand the movements, the pressures, the weight, the resistance, the interaction you're having with that virtual patient inside this space. So we can provide the guidance that comes through from that, whether it's presented visually in the way that you see it here or audibly in the way that you just saw with the bot. And of course, the bot doesn't have to have any physical presence. What we've found with some of the work we've been doing with this, particularly in the ophthalmology space, is some really interesting correlations between the inputs that we have, the telemetry that we have, and our ability to start to predict what's going to happen. Now, we're still at an early stage in this, but we're now applying it into a cataracts system that we have in place with Orbis, the eye charity, where we can actually predict what's going to happen based on your telemetry at the point within the procedure and say, well, actually, Richard, maybe you should just adjust your pressure there. Maybe you should adjust your technique because you're likely, not definitely, but you're likely to have an adverse effect. So it's a really interesting thing. And again, it's early stages for us, but it's moving and coming into our platform as we speak at the moment. Again, recognising expert movement, recognising novice movements, and allowing us to, again, feed that into both the information about your training, but also predict and inform your knowledge and your capability as you go through the different scenarios. So in conclusion, as I said, I think, and this is an example from one of our cardiac systems for nurse training, not for practitioners, looking at hemodynamics. But it's a case of really when this becomes established, and there's a few technical challenges that we're working on and others are too, to make this an everyday occurrence so that it becomes just part of the modality of learning and education within our space. If you'd like to know more, our website's there, my email's there as well, but our website has lots of our studies and further information on the tech stack. Thank you.